Hi kitties. Today we're going to actually look at reduction potentials and how we measure those in a laboratory. So this is our first online lab. So what is this lab about? It's measuring the voltage potential between different metals. Okay, so I'm going to show you how to do that in a minute. Now, let's go through the background together. Background says every species has the ability to lose or gain electrons. A reduction potential is a measure of the energy potential measured in volts for a species to undergo reduction, which is a gain of electrons, relative to another species serving as a reference. The more positive the value, the voltage value, the greater the tendency for the species to be reduced. From this data, one can also deduce potentials for oxidation by simply reversing the reduction reaction and changing the sign of the potential. That makes perfectly good sense, right? So what, first of all, is this voltage and potential idea? So if I'm holding my cell phone and I let it go, obviously it had potential energy that was converted to kinetic energy. But if I lift my phone up higher, what's happening to the potential energy? It's going up. So that is kind of like what we're measuring here in voltage for electron movement. So there's a certain energy between my hand and the phone now. That's kind of like a voltage. It's a potential difference. If I increase that distance, the potential becomes greater. The voltage gets greater. Simple enough. The electron potential between one point and the other is a voltage. So today we're going to be looking at 6 different metals and measuring the potential difference between the 5 of them against a reference. So I have some zinc, I have some iron, I have some aluminum, I have some copper, I have some lead. Some zinc, did I say that? Well, you can see all the reactions up above. So these are all the reduction reactions from their ion into their metal. You'll notice all the ions are gaining electrons. That means they're reducing. So these 6 reactions above are reduction reactions. So let's take a look at this procedure here. It says we're going to affix an electrode to a clamp so the electrode is bathed in acetic acid solution. That's vinegar, by the way. We were actually supposed to measure the concentration of that vinegar because it's my homemade vinegar. Our acid-base lab was going to figure out the percentage of that, but vinegar is a 5% acetic acid solution. We're going to record the metal as a reference in the data table below. We're not going to use copper and magnesium, and I'll explain why in a bit. We're going to attach that to the black wire of a voltmeter, and the red lead measures the voltage of the reduction reaction relative to the oxidation taking place at the black electrode. I'll explain that in a second. We're then going to attach the red wire from the voltmeter to the other metals in the set one at a time and place them in the solution and record the voltage for each combination. So let's talk about what this voltmeter does first of all. So how are we going to be measuring voltage? We're going to be using this little tool called a multimeter. I called it a voltmeter, but it can measure voltage, amperage, and resistance as well. We said that the voltage is just simply a potential difference for the electrons to move. It's, potential difference between 2 points. We measure that in this unit called a volt. I'm sure you've heard of volts before. And there are 2 wires. There's a black wire and a red wire coming out of the multimeter. And I've got it selected to a DC voltage. Now, how does this thing work? When I have something attached to the black electrode, if it's undergoing an oxidation, the electrons are lost at that point. So the electrons are going to flow in this direction, meaning that the other side, they'd be flowing in this direction towards something undergoing reduction. We know reduction is the gain of electrons, oxidation is the loss. When we have that situation, our multimeter is going to register a positive voltage. If, however, we have the electrons flowing in the opposite direction, if they're coming from the black to something undergoing reduction and away from the thing that's attached to the red one undergoing an oxidation, this will show up as a negative voltage. So red wire to a reduction, red to red, that's a positive voltage. If what's attached to the red lead is undergoing oxidation, it will show up as a negative voltage. So I've set up my experiment so that now I have my multimeter set to the voltage. I have the red wire coming out of the multimeter attached to this white wire. I have the black wire coming out of the multimeter attached to the black wire, which is attached to my reference electrode. I need someone to compare everything to, and on the list that we had, I just selected lead. So in the lab, I have put lead Pb in for my reference electrode. Now what we're going to do is look at the voltage of different metals. So I'll start with the magnesium. So I'm going to clip the magnesium on here. And I'm going to put that into the acetic acid solution. And you'll see it registers a negative, about a negative 1.34 for the magnesium. And now I've recorded the magnesium as negative 1.34 volts. And again, that negative sign is going to tell us something. Let's try the other metals. Okay, this time I have copper metal in with the lead. And again, I can't let them touch. But now what do I see? Positive 0.20, I'll say. I recorded that in my data table. Copper is positive 0.20 volts. Now I have a piece of zinc attached. I'm going to put that in with my lead and see how that looks down there. And what does it say? Negative 0.46. And I recorded that one there. This time I have a piece of aluminum in with the lead. Negative 0.02 volts. Okay, so my aluminum's at negative 0.02 volts. My last metal is the iron. So the iron goes in. And so there's my 0.05 volts for the iron. Now, we've got all our data. Let's get together and figure out what all this means.